Assalamu alaikum viewers. We'll continue the topic kinematics of motion in a straight line. In the previous videos, we learned about the displacement and the distance difference. We differentiated and we discussed their graphs, and also we discussed how can we find out the velocity and acceleration through the function given. Either it's a distance function or velocity function. We solved uh, a question as well. Now we'll continue the same topic and we'll solve a question, past paper question. Let me download from my drive. This is the question number one. Okay, question number one. Okay, sorry for the delay. Inshallah, I'll do it next time. I'll do this before. Okay, we'll paste it here. So you're given a question that in this question, this is question of 2006, question number two, paper P3. Okay, sorry, pure mathematics, this mechanics paper four. Question number one, a motorcyclist starts from a rest at A and travels rest at A. So we'll highlight this information from rest at A in a travels in a straight line until he comes to rest at again at B. So started with rest and becomes at rest at B. The velocity of the motorcyclist t seconds after leaving A is v meter per second, where v is equal to the v is equal to, you are given the function v is equal to t minus 0.01 t square. Now in part 1 they are saying that you have to find out the time taken for the motorcyclist to travel from A to B. So you know that at A the velocity was 0, at B the velocity was also 0 because at A it was rest and it becomes to rest at again at point B. So that means velocity is 0 at A and B. So if we taking at V is equal to 0, this will become 0 is equal to t minus 0.01 t square. And if you factorize it, taking t as common, 1 minus 0.01 t equals 0, t is equal to 0, or 1 minus 0.01 t is equal to 0. Now you got t is equal to 1 divided by 0.01. T is equal to 100 seconds. So you got two values when the velocity was 0, two times when the velocity was 0 at t is equal to 0 seconds and t is equal to 100 seconds. That means velocity was 0 at A. Obviously, the time was 0 at this time when it was at A, and velocity was 0 at B, and when the time was 100 seconds. So the time taken from for the motorcyclist to travel from A to B is, so time taken from A to B is equal to 100 seconds. Okay, part B is the distance AB. So you have to find out the distance between the A and B. So you know that the total time taken by the motorcyclist is 100 seconds to reach to B. And now, as we have to find out the distance, you know that we are given the function for V is equal to T minus 0.01 T square. Okay, now V, you know that V is displacement, change in displacement or change in time is equal to T minus 0.01 T square, and ds is equal to T minus 0.01 T square into dt, taking integration on both sides. This is integration of 1 ds. There is when there is nothing, that means there is 1, and integration of 1 is s equals to t square over 2. You know that you have to, the power is 1, so 1 would be added and 1 plus 1 would be divided in the integration, and this will become minus 0.01 t raised power of 2 plus 1, that is 3, divided by 2 plus 1, which is 3, plus a constant k. Okay, so s is equal to 1 over 2 t square minus 1 over 300 t cube plus k. You know that when t is equal to 0, when t is equal to 0, s is equal to 0. So 0 equals 1 by 2 into 0 square minus 1 by 300 to 0 cube plus k. So k is equal to 0. You got the constant value. Now substituting back it in the equation, this one, so that will be, you got the displacement function as 1 over 2 t square minus 1 over 300 t cube. Now you got the displacement function. Now you need to find out what was the distance AB. So AB, so if you remember that we found that the total time taken for from A to B was to reach from A to B was 100 seconds. So now, as this function is on displacement time, so at t is equal to 100 seconds, substituting t as 100, displacement is equal to 1 over 2 to 100 square minus 3, 1 over 300 into 100 cube. So this will be equals to, displacement will be equals to 1666.67 meters. So that means distance AB, distance AB is equal to 1666.67, and according to the uh, requirement, if you round it off to three significant figures, so this will be 1670 meters. Okay, we'll solve another question. Question number 2. Let me download again from, okay. Okay, so we'll take the image. This is the paper. This is also 2006 paper, 2006. And okay, In this question, they are saying that you have to, the diagram shows the velocity time graph. This is the velocity time graph for the motion of a small stone which falls vertically from rest at a point A above the surface of a liquid container. So I'll make this container for you. This is like this. This is the container, and this is the surface, and there is a point A above, and from where the stone is dropped, right? And it touches the surface, and then it went down to the bottom of the container, right? This is the situation. So let me make a small diagram for you. Okay, this is the container, and this is the surface of the container. This is point A. From there, the stone is dropped to here and then went to the the bottom of the container, right? Okay, falls from vertically from rest. From rest means the velocity was zero. Point A above the surface of the liquid in a container. The downward velocity of the stone t seconds after leaving A is v meter per second. Okay, leaving A. So that this point, leaving A is v meter per second. That means velocity starts from here and it was rest at this point, and then the stone this hits the surface, hits this surface, right, of the liquid with velocity 7 meter per second. That means started from rest, and when it reaches to here surface, the velocity becomes 7 meter per second. And then at t is equal to zero point 0.7. At this time, the time was zero point 0.7. That means it took 0 0.7 seconds to reach to the surface of the container. It reaches to the bottom of the container with velocity 5 meter per second. Then the stone reaches to the bottom with velocity 5 meter per second. Got it? And it took 1.2 seconds till 1.2. That means it took zero point 0.5 seconds to reach from the the uh, surface of the above surface to the bottom of the container, right? Okay, this was the situation. I wanted you to understand what the situation is. Then you can, if you know the situation clearly, you can solve this question, very easily. And if you don't know the situation, what the situation is, so you cannot, your approach will not be as accurate as it should be. In part A, they are saying for the height of A above the surface of the liquid. You have to find this height, this height. You have to find out this height. So height, what is this height equals to? H. This H is actually the distance traveled by the stone from point A to the surface of the container. So this is this area in the graph. So you know that in velocity time graph, area under the graph is what? The distance. So we'll find out the part 1A, the area under the graph, area of uh, mm, height, height of A is equal to, that would be 1 over 2 into 0 0.7. Base into height is 0 0.7 as well. And that will become, if you do the calculation, use your calculator, that will become 2.45 meters. I'm sure you have got it. This height from here to here, this is 2.45 meters. And this is the area, this is the area. In 0 0.7 seconds, the stone reaches to the surface of the container, right? Okay. Now, part B is the depth of the liquid in the container. The depth of the liquid in the container. Okay. So this is the depth of the liquid in the container. This one. So this is when the after this is the point where the stone hits the surface, and then it goes. It started decelerating and it reaches to the bottom. This is bottom, right? And this is the surface. So area under this graph will be the area which is the distance between the surface of the container and the bottom of the container, right? Okay, so what you are going to do, you have to find out the area of the this trapezium. So I'll do it. मैं इसको जो है वो green कर देता हूँ. Okay, this is, let me write down which one is for part A and which one is for part B. This is part A and this is part B. So 1A, sorry, and this is for one part B. So if you find out the area, that would be 1 over 2. This is what we were supposed to find out. We were supposed to find out the depth of liquid in the container. So depth of liquid in the container is equal to 1 over 2 into height. Height is 0.5. This is the height of the trapezium. And this is parallel side. This is 5 and this is 7 parallel sides. So into 5 plus 7. And if you use your calculator, you'll find out that this is equals to 3 meters. Okay, the next is the next part is, hope you have understood this. I'm sure you have got it. This is part A and this is part B of one. And if we look at the part two, find the deceleration of the stone while it is moving in the liquid. So deceleration we have to find out from this one. This is the deceleration while it was moving downwards from the top surface to the bottom, right? Okay, what is deceleration equals to? Part 2, deceleration. So deceleration is equal to rise over run. So what is rise? This is 2 and run is 0.5. So this is 2 over 0.5, 2 over 0.5 meter per second square. So this will be 20 divided by 5, that will become 4 meter per second square. So you got the deceleration. So when you are writing down the deceleration, you are not going to write down the sign with this. If you are writing down acceleration, then you'll put the negative sign with the over the minus. You write down -4 instead of writing 4. But when you are writing deceleration, you are not going to write it -4 meter per second square. Okay. The next is, given that the resistance to motion, let me copy it down from here. Okay. We are saying given that the resistance to motion of stone while it is moving in the liquid has magnitude, this is the resistance given, 0.7 newtons. Magnitude, the resistance to motion, right? And find the mass. You have to find out the mass. So the when the stone is thrown inside, so what is its driving force? That which is bringing the stone downwards. That is its weight, and weight is mg. So that means if driving force here is mg, what is drive, which is driving the stone downwards, that is mg, that is weight. So we'll write down the equation first. Driving force minus resistance force is equal to force net, that is ma. So driving force is mg minus 0.7 Newton is equal to m into, as it is deceleration, we'll write down minus 4. So mg is 10. We'll take this, bring this 4m to this side. This will become plus 4m, and 0.7 will become positive 14m is equal to 0.7. M is equal to 0.7 over 14, and M is equal to 1 over 20 kg. Or you can write down, better is to write down in decimals, 0.05 kg, right? Hope you have enjoyed the lesson, and you have understood how to utilize the concepts of kinematics in solving the word problems. Thank you very much. Do subscribe my channel, and if you have not understood something, you can talk to me in comment section. Allah Hafiz.